us study Huygens principle. Let us first understand what is a wavefront. When we drop a small stone on a calm pool of water, waves spread out from the point of impact. Every point on the surface starts oscillating with time. At any instant, a photograph of the surface would show circular rings on which the disturbance is maximum. Clearly, all points on such a circle are oscillating in phase because they are at the same distance from the source. Such a locus of points which oscillate in phase is called a wavefront. Thus, a wavefront is defined as a surface of constant phase. The speed with which the wavefront moves outwards from the source is called the speed of the wave. If we have a point source emitting waves uniformly in all directions, then the locus of points which have the same amplitude and vibrate in the same phase are spheres, and we have what is known as a spherical wavefront. At a large distance from the source, a small portion of the sphere can be considered as a plane, and we have what is known as a plane wave. Huygens' principle is essentially a geometrical construction which, given the shape of the wavefront at any time, allows us to determine the shape of the wavefront at a later time. Now, let us consider a diverging wave and let F1, F2 represent a portion of the spherical wavefront at t is equal to 0. According to Huygens' principle, each point of the wavefront is the source of a secondary disturbance, and the wavelets emanating from these points spread out in all directions with the speed of the wave. These wavelets emanating from the wavefront are usually referred to as secondary wavelets, and if we draw a common tangent to all these spheres, we obtain the new position of the wavefront at a later time. Thus, if we wish to determine the shape of the wavefront at time t is equal to tau, we draw spheres of radius v into tau from each point on the spherical wavefront, where v represents the speed of the waves in the medium. If we now draw a common tangent to all these spheres, we obtain the new position of the wavefront at t is equal to tau. The new wavefront, shown as G1, G2, is again spherical with center SO. But the above model has one shortcoming. We also have a back wave which is shown as D1, D2. Huygens argued that the amplitude of the secondary wavelets is maximum in the forward direction and zero in the backward direction. By making this assumption, he explained the absence of the back wave. However, this assumption is not satisfactory, and the absence of back wave is really justified from more rigorous wave theory.